Hello, I am Clément Gagnier with Siemens PLM software. Today I am going to present you the port compatibility between powertrain and 3D mechanical libraries. In LMS ImagineLab AMSIM, vehicle submodels of the powertrain library can now be connected to the components of the 3D mechanical library. Actually, the ports of the vehicle, chassis, suspension and tires are now compatible with the ports of the 3D mechanical components. Two practical applications will be shown here in order to illustrate the interesting possibilities of this feature. So first, we'll see the possibility of multi-axle modeling, and then an example of an advanced suspension model, McPherson type. So let's take this very simple model of a truck with 3 axles. So this is the chassis model here. And if we have a look at the external variable, we see that the port type at the wheel are now 3D mechanical ports. So variable exchange at port are the forces in the 3 dimensions, the torques in the 3 dimensions, and in the other way, all the kinematics elements in 3 dimensions. So this chassis is connected through what we call 3D nodes in order to model the front axle here, the center axle and the rear axle. Also, you can note that the suspension component have also 3D ports to be compatible with the node. So let's model a 4-axle vehicle just simply by copy-paste these components here and using another 3D node on top of these two. So you can cascade the 3D nodes together in order to model multiple axle vehicles with no limitation in number of axles. So this was for the first example. Now I will open another model to show you another possibility of this feature, which is the integration of an advanced model of McPherson suspension inside a simple vehicle model. So we have the same model of chassis here, which is connected to 3D mechanical components here to model the McPherson suspension. So this is for the front axle, and we keep very simple suspension for the rear axle. So the McPherson suspension is modeled with elements of the 3D mechanical library. So here we can find the spindle, which is the blue element here. Then we have the lower control arm here in green, which is this component here. We have the spring and damper body in purple here, which correspond to this element in the drawing. And we have the steering tie rod in brown here. So you can parameter this model with what we call hard point. And so these are the coordinates of all the main points in 3D space. So you can change the coordinates of the hard points simply by editing the global parameter. So here I have opened the global parameter window and I can change the values of all these coordinates. Okay. So the purpose of such a model is to study the influence of all these components on the vehicle NVH, nose, vibration and harshness. So, for example, let's say we would like to have a sensitivity analysis on the coordinates of the hard points, or we can choose to make an optimization of the stiffnesses of the bushings. So the stiffnesses of the bushing are these components here for the upper bushing, and these components here for the lower bushing. So let's have a very simple example with this model This is just a tip-in, tip-out maneuver. So I have launched a simulation with an input torque, a drive torque here. So at this moment, at 2 seconds, we have a tip-in and then a tip-out. We see that the vehicle speed is increasing, and we see that the longitudinal acceleration have this characteristic here. We can notice that there is a quite huge peak in the oscillations that we can study and then try to decrease. Thanks to the 3D mechanical library, we have access to automatic creation of 3D animation. By double-clicking on this icon, I will open an animation with the McPherson suspension, which is directly connected to the model. I can animate this model and have different views of the suspension. At 2 seconds, we will see that the suspension spring is moving, representing the tip-in phenomenon. And then, at 5 seconds, we will see the consequences of the tip-out. Now. So this view could help the user to understand what is the behavior of the suspension and the vehicle. So as a conclusion, we have seen two practical examples of usage of this 3D port compatibility between Powertrain library and 3D mechanical library. So multi-axle vehicle and advanced McPherson suspension model. Thank you for watching. For more information, please visit our website.